Started working in Indian Point in 1980. In 1983, I got my senior reactor operator's license at Indian Point 3. I spent the next 32 years in the Indian Point 3 control room. In 2015, I escaped the control room and began working on placing our spent fuel into dry storage, which I'll show you in a little while. And over the years, I kind of became the official unofficial photographer and kind of historian at Indian Point. So let's get into the history a little bit. So from the early 1800s and for easily over 100 years, steamships ruled the Hudson River. And let's see. All right, first problem, Bill. Advance. It's just working. As I mentioned, steamships ruled the Hudson River, and there really wasn't a wharf or a dock anywhere between New York City and Albany and even Troy, 150 miles, that wasn't served by some sort of steam-propelled vessel, whether for freight service or passenger service. And the biggest of these companies was the Hudson River Day Line. And some of you may remember it. I remember getting on the steamship Alexander Hamilton in the early 60s at the Yonkers City Pier with my family, going up to Bear Mountain. You know, we had our grill and our bag of charcoal, and I'm sure a lot of you remember that. But by the 1920s, the Hudson River Day Line Company was trying to find a way to compete with Bear Mountain, because every day thousands of people would get on these ships on the west side of Manhattan. More people would get picked up at Yonkers. They go up the river, and everybody get off at Bear Mountain, and the ships would go up the river to Poughkeepsie and turn around with empty ships. So if they could figure out a way to have their own park, they would have captive customers all day long. So what they did was they bought 320 acres right below Peekskill, and here's a photograph. They built their own park. And the park was a pleasure park. It had walking trails, and it had a picnic area, it had a playground. It did have a beer hall, and it did have a dance hall, which is right here. When the ships came to the park from the city, you bought your tickets for the park here. You could also buy food here. On the weekends, bands came up on the ships, and they would relocate to the dance hall. So this park opened up on June 26, 1923, and it was a very popular spot for many years. Here are some other photos. One steamship arriving. There were two piers at the park. You can see the dance hall here again, and I believe that's the beer hall right there. It was a first aid station. One ship arriving, one ship leaving. And here's a shot from the park itself. And again, a pleasure park, just like Bear Mountain. They gave it the name Indian Point. Indian Point was a completely made-up name. They wanted to attract the younger passengers they had. You know, you could decide where you wanted to go, Indian Point or Bear Mountain. What sounded cooler to you? But it's a totally made-up name. In 1929, they built a 100 by 150 foot pool. At the time, it was one of the largest pools on the East Coast. They had bath facilities for 1,500 guests. So this obviously increased the popularity of the park. In this picture, this is 1938. And this photo, and the next photo was given to me by a coworker. This little girl right here, 10-year-old Marion Ackerman, she's with her father, Henry, and they just got off the Henry Hudson at Indian Point Park. And Marion's son would go on to have a long career at Indian Point. A friend of mine, a 37-year career, his name is Gary Heinrichs, and that's who gave me this photo. That's his mom, Marion, and there she is again with her mom, Philomena. So when you got off the boat, these teepees were located right on the side of the dock, and this just gave more credence to the name of Indian Point. These people gave demonstrations. You could buy headdresses and things of that nature, blankets. And the park was very popular, but by the 1950s, people decided or discovered they could get in their cars and go other places. So Indian Point Park went out of business in 1948. And the property was sold and then quickly re-auctioned off. And it was sold to this gentleman in the middle here. His name is Emanuel Kelmans. And he was going to turn the park into a real full-fledged amusement park. And this is the ribbon cutting ceremony for 1949. He opened the park in May of 1950 as a totally different park. Now we had arcades, Ferris wheel, all sorts of different rides. We had refreshment stands. Mr. Kelmans had an agreement with Coca-Cola that only Coca-Cola products would be sold at the park. This photograph taken in 1952, this is actually June 11th. This is retired Admiral Bull Halsey right here. He traveled to the park on the steamship Peter Stuyvesant, and he came on the 23rd annual outing of the Institute for the Crippled and Disabled, and he gave out awards for rehabilitation on the ship. There were 1,405 disabled persons on the ship, and they had a box lunch when they arrived at the park, and this is 1952. There were powerboat rides you could go on down at the dock, 25 cents for a ride. This was part of the 189 Liberty ships from World War II that were anchored across from Indian Point and all the way up to Bear Mountain, basically around the corner. This is a tram that would take people from the parking lots and take you into the park, into various locations around the park. This ride here, Dodgem, is actually bumper cars. And you can see the sign there. They had the Westchester County Fair at the park in 1952 and 1953. But after owning the park for about 5 years, Mr. Kelmans decided to sell the park. He sold it to Con Edison on October 8th, 1954 for $250,000. And at that time, Con Edison was interested in buying property wherever they could. They estimated a huge increase in the demand for electricity in both New York City and Westchester County over the next 15 to 20 years. So they needed to build power plants, and this was one of the places that they had bought. Now the park remained in operation for 2 more years in 55 and 56. It gave the owner time to give his concessionaires and his employees time to find other jobs. And here's a headline of the Peekskill Evening Star. It's October 8th, the day the property was sold. Atomic power plant to be built at Indian Point. So at this time in the 50s, after President Eisenhower signed the Atoms for Peace agreement, many of the large utilities in the country, Con Edison, Commonwealth Edison, were looking to build their first nuclear power plants. And this is the Con Ed example. And here we are. This is 1956. Construction has started right here on Indian Point 1. And you can still see the dance hall there. And the pool is empty, but it's still there. And there's some ball fields out here. We believe the pool is still there today. It's a parking lot. We call it the gravel lot. And we believe the pool is still under the gravel. But in this picture, you can see the construction of Indian Point 1. Indian Point 1, that's a metal sphere, a metal ball that's being constructed right there, 160 feet in diameter. That would hold the reactor and all of its components someday. And this building on the outside, that concrete building, will be a radiation shield that will shield this sphere from radiation outside. And this is May of 1960, May 1st actually. Here is the reactor vessel that has been brought to Indian Point by barge. It came from Babcock and Wilcox in Barberton, Ohio. 230 tons. It's being moved into the containment building here, the radiation shield that I mentioned earlier. And here's another photograph. This is like 2 days later, now being slid into the containment building to eventually be put into place. So, I mentioned reactor. This is what it looked like. This is the Unit 1 reactor vessel. You can see a person standing here for relative size. In the center of this reactor would be the nuclear fuel. Originally, it ended up being uranium fuel, but Here would be 120 fuel assemblies. And what a fuel assembly is a collection of fuel rods or fuel tubes. Each one is about 5 inches square, 5 by 5 inches, and about 10 feet long. And they would be housed right here. Water would come in the reactor from the bottom, the inlet nozzle right here, and the water would go through the fuel where it would get heated up by the fuel, and then come out the bottom, come out the top at the outlet nozzle. And this hot water would come out and in turn make steam in what was called a nuclear boiler. So this is what the reactor looked like, pretty much one piece except for the head, which gets bolted on so the fuel can be replaced right here. This fuel was originally thorium. The first core was thorium, but it was eventually changed to uranium. That's a long story. This is for fuel assemblies from Indian Point 1, and as I mentioned, about 5 by 5 inches, about 10 feet long. And if you look through these holes here, you can see the tubes that held the uranium dioxide pellets, which caused the fission process and which generated the heat. And I've got a couple experts in the crowd if they want to correct me on anything. But this is how a nuclear power plant works. It uses fission. So what happens is you have a uranium atom, which is struck by a neutron at high speed. The atom becomes excited and eventually splits into two. And that's the fission process. And when it splits into two, it gives off a few things. It gives off 2 to 3 other neutrons, which can cause more fissions, and it gives off a large amount of heat. And that's how a nuclear power plant works. That's the source of the heat, the fission process. So here at Indian Point 1, this is a cutaway. You can see this is where the reactor lived, right in the middle, down in the bottom here. And as I mentioned, the cooler water came in at the bottom, went up through the fuel, got heated up, came out through the top. And these things here, called nuclear boilers, are where steam was generated to eventually exit the building and turn a turbine to make electricity. Now today, this is the top floor of the containment building inside. This is called the 108-foot elevation. And the reactor and all its components were accessible by plugs and hatches in the 108-foot. This is the polar crane, which was used to move all that equipment around. So today, this is what it looks like. This is a recent picture of the 108-foot. Again, the reactor and all its components are below the floor. And this is the polar crane, which was used to handle all that equipment. And this is a picture looking down from the 108-foot with one of the hatches removed. This is a 13-foot hatch that's been removed. And you can look down in 1962. This is before the plant ever operated. This is the reactor right here. And it's in the floor of this, what we call the reactor cavity. And up here, a person is operating the manipulator crane, which handles the fuel assembly. So they're doing some testing right here of the system, because this crane will eventually load the 120 fuel assemblies into this reactor. So again, 1962, before the plant has ever operated, brand new. And this picture I took 2 years ago, 50 years later. The plant hasn't operated since 1974. We removed that same hatch, and you can see the reactor is still in the same location. But in this picture, the head is on, and it's held on by 50 large bolts that are 5 inches in diameter. And again, this plant hasn't operated in almost 50 years. In 2020, when we started going into Unit 1 again to do some work, nobody had been down to the reactor vessel in like 20, 25 years. So this was the first entry down the ladder to the reactor vessel head. And this was the RP technician. His name is John Dorsey. And an RP technician is a person who measures the radiation fields, and they're always the first person to go into an area to measure the radiation fields for future workers. So John was the first one down the ladder. And this next slide is a little video of that I can show you.
Johnny, yes, sir. We're good? Okay. Okay, then we go. How's it look, Johnny? You okay? Yeah.
So that's what it looks like down in the Unit 1 reactor cavity. And that was first entry, like I said, in 20, 25 years. We started doing some work down there after that. We're still in there today doing work.
John,
So this is what the Unit 1 head looks like today. Again, 50 bolts that hold the head on. Each one is about 5 inches diameter. And someday this reactor vessel will be removed whole, is the plan right now from this building when it's decommissioned.
It'll be what?
Decommissioned?
Before that, someday it'll be,
It will be removed whole, in one piece.
oh.
The reactor
oh,
will be
okay.
moved in one piece. So this is the finished Unit 1, back in the early 60s. You can see the containment building here where the reactor is, where we just were. Now, Indian Point 1 was a little different. It was 65% nuclear and about 35% oil superheat. So this is an oil superheater right here. And there's the oil tanks. So the steam exited the building. It was heated even further to superheated steam here in the superheater. And then it came into the turbine building where the turbine is located to spin the turbine and the generator. You can see that. That's the Unit 1 turbine generator. The steam enters these turbines right here, spins them at 1800 RPM, spins the generator, which makes the electricity. Indian Point 1 made about 265 megawatts at full power. This is the control room of Indian Point 1. This is a modern day photo, so many of the controls and things, it's all abandoned and disconnected and shut down, but this is what it looked like. I don't have a real great picture of the Indian Point 1 control room during operations. So this is a modern day picture of what it looked like. This photograph, this gentleman here is Jerry Walden. He was the Unit 1 control room supervisor, let's say, back in the early 70s. And he's sitting in the Unit 1 control room, and he's looking over into the Unit 2 control room. When they decided to build Unit 2, they kind of punched out the wall, and they built the Unit 2 control room over here. So the two were in the same room, and Jerry is looking over at the Unit 2 control room construction. So that picture's from about the mid-70s, and this is what that same spot looks like today. So over the years, as Unit 2 operated, they kind of cannibalized a lot of the Unit 1 control room for additional controls and instrumentation, and you can see everything's become digital with screens and monitors and things like that. So again, back to this, and this is today. Now, Indian Point 1 only ran for 12 years. It was shut down in 1974. As nuclear power plants were being built, the NRC, the federal government, came out with more and more restrictions and more requirements for nuclear power plants. Indian Point 1 did not have an emergency core cooling system. Con Edison began installing one, but at some point decided that the cost could not justify the continued operation of the plant, so they shut it down. And at the time, they knew they were going to build Indian Points 2 and 3, which would be much, much larger plants. So Indian Point 2, construction began in 1966, and Unit 3 began in 1968. Now these plants would be Westinghouse 4-loop pressurized water reactors, and it was the type of reactor that many utilities in the country were building at the time. So, like I said, these would be much bigger plants, and they kind of gave up on IP1 at that point. In Indian Point 2 and 3, the reactors would be much larger. Instead of 40 feet, they're 43 feet. Instead of 235 tons, they're 435 tons. And the core, which would be right here, instead of being 120 fuel assemblies, it would be 193, and the fuel would be larger. Now they're 8 by 8 inches, they're 13 feet long, and they each weigh about 1,500 pounds. And this is what a fuel assembly at Indian Point 2 and 3 would look like. They were 15 by 15 fuel rods, and inside these fuel rods would be these uranium dioxide pellets. And this is what a typical Westinghouse 4-loop pressurized water reactor system looks like. You've got a reactor in the center. Water is pumped in at about 500 degrees through 4 separate places, the 4 cold legs we called it. Water would go down the side of the reactor and up through the center. And then it was heated by the core in the center, and it came out what we call the hot leg. And in the hot leg, it entered into the steam generator. And I'll show you a better picture of that in a second. Okay. So again, Water was pumped in around 500 degrees, went down the side of the reactor, up through the center where it was heated by the core, came out at about 600 degrees. This is the hot leg. And it came to the steam generator. Now the steam generator was a bunch of U-tubes that held the reactor coolant water in it, actually 3,000 U-tubes. And those tubes were very hot, 600 degrees. And around those tubes, the yellow was called feed water. And the feed water was heated up by those hot tubes, and steam came out the top of the steam generator, which came over to the turbine, spun the turbine, which in turn spun the generator. That's how Indian Point 2 and 3 worked. And when you look over at the containment buildings on the river, it's mostly empty space. The reactor cooler system and the reactor was down in the center, down low, mostly underground. You can see the 4 steam generators surrounding it. So construction, this is a construction photo. This is Indian Point 2, sitting right next to Indian Point 1, which I'm sure was still operating at this time. The containment building is being built right here. This is the pedestal that will eventually hold the turbine generator. They're building pumps on the river, circulating water pumps. This is inside the Unit 3 containment building. This is 1970. It was a huge amount of work to build these places, folks. The concrete in many places is 3 to 4 feet thick. Everything is reinforced with steel rods, rebar. This is the area where the reactor would someday be. So these were huge projects employing thousands of people around the clock. In this photograph, Indian Point 2 is in the background. It's almost completed. Indian Point 1 is here in the center. And this is the Indian Point 3 containment building being constructed. You can see the rebar being woven. This is like 3 and 4 inch diameter rebar. And after they completed a section, they pour concrete around it. This crane is the Unit 3 polar crane. It runs on a circular rail, which is called the crane rail. And it's supported by a wall inside the building. And this crane would be used to construct the plant and also to do maintenance of the plant over the next decades. And it's still being used today, the polar cranes, in both Indian Point 2 and Indian Point 3. And here's a closer shot of the rebar. You can see, you basically almost can't see through it. There was also metal plates inside, but here they are just welding all this rebar together before they pour the next level of concrete. You can see the polar crane up above. And here comes one of the reactor vessels by barge coming into Lentz Cove just below Peekskill. There's the old Fleischmann's factory. You can see the reactor here, and the head is right behind it. And here the Boilermakers are sliding the reactor vessel off the barge. Every reactor in the country from Westinghouse came with one of these sleds or skids. It weighed 70 tons by itself. But it was used to slide the reactor into place and get it onto the trucks and things like that. And there's the head located behind it. So the vessel weighed about 430 tons and the head weighed about 170 tons. And here it is arriving. This one is coming into Unit 2. You can see this crawler they have to move the reactor vessel from Lentz Cove up into the plant site. And here it is in the containment building. Again, still on its sled. And it's now hooked up to the polar crane. You can see 2 steam generators are already in place. And now they're raising it to its vertical position. Once it gets vertical, they will lower it into the reactor cavity where its permanent home will be. And there it is being lowered into the reactor cavity. So you can see I mentioned before the cold legs and the hot legs. 4 of these are cold legs and 4 of them are hot legs. So there's 8 nozzles around the circumference here. Here's one of the steam generators also arriving at Lentz Cove. Gerosa was the company that did all the heavy lifting back then. Here, one of the Indian Point 2 steam generators is making the turn into the plant. This is the corner of Welcher Avenue and Broadway. And right behind the cab here is our Johnny Ritz Bar and Grill. I could have written a whole nother book on that place. And finally went out of business a few years ago, but a very common place during the operation of the plant. And here's a steam generator being brought into the containment building. You can see, as I mentioned before, 2 are already in place. This is the 3rd one coming in. This looks like it's July 1971. So now the reactor's in place. This is looking straight down into the Unit 2 reactor. I told you the core would be located here. Right now it's empty. There's no fuel in the core, but that's where the 193 fuel assemblies will be located. And the water that comes up to get heated comes up through those holes in what we call the core plate. So as it comes right up to the fuel and then up to the hot legs, which you can see right there and there, there and there. Now here we are loading the first initial core at Indian Point 2. Now the reactor vessel is partially filled with water. This long tube here is called the mast, and it's connected to a crane up above called the manipulator crane, which rides on rails over the reactor cavity. You'll see that in a minute. So now the core is completely loaded. 193 brand new fuel assemblies of the initial core for Indian Point 2. And there's the mast in the corner. Doing some final inspections. The next thing to do would be to put the upper internals in and then to land the head. And here's the reactor vessel head. Now it's got its control rods and various things installed on top of it. And it's one full piece. At the same time, we're building the reactor system in the containment building. We're also building the turbine generator inside the turbine building. Here are the 3 low-pressure turbines, which will eventually get steam to turn this one shaft. So this is Indian Point 2, 1969. And this is the main generator. And when it's completed, and you spin that thing at 1800 RPM, you get 22,000 volts out of it. And you'll see more about that. Here is the generator rotor being slid into the stator here. 1969. All these components are extremely heavy. This is a typical Westinghouse turbine generator from that time, which we have today. So steam entered into the building from containment. It first entered a high pressure turbine, a small turbine, came out, got reheated, and went back in and went into the 3 low pressure turbines. So this shaft is all one piece. And when operating, it spun at 1800 RPM, and it spun that generator there, which again made the 22,000 volts. This is what a turbine rotor looks like. This is one of the low pressure turbines. Steam would enter the center and go out from towards both ends. And you can notice that the blades get bigger and bigger as you go outward. As the steam lost its energy going outward, the blades had to be bigger and bigger to exert the same amount of torque on the shaft. Here's a video. During the construction of Indian Point 2 and 3, you can go on a tour. And I remember coming up from Yonkers in my dad's 61 Ford Fairlane to go on this tour. Little did I know I'd spend the rest of my life here. But this is video. A local gentleman had this 8mm video from the early 70s. You can see Indian Point 3 is being built. Indian Point 2 looks like it's completed. It was a visitor center where you got pamphlets, you watched a movie, got a little bit of a lecture. I do remember a big guy in a blue cotton hard hat. So Indian Point 2 went commercial on August in 1974, and it was an 875 megawatt plant, and Indian Point 3 was August of 76, slightly larger, 965 megawatts. Now, in the mid-1970s, Con Ed started running out of money to complete Indian Point 3. They were also building Paletti project down in Queens at the same time. So the state kind of bailed them out. The New York Power Authority purchased Indian Point 3 in 1975. Con Edison continued its presence at Indian Point 3 for a few years and got the plant finished and started for the Power Authority. But the Power Authority took over around 1978, I believe. I started in 1980, but this is the dates of commercial operation. And here today, this is what the Indian Point 2 turbine generator looks like. There was a point in time that the original Westinghouse generator had to be replaced, and the only one available at the time was a General Electric version. So this was installed in the mid-90s, I believe. And this is the original configuration. This is Indian Point 3, which still has its original main generator. Other than that, the same, low pressure turbines, exciter, moisture separator reheaters. And this is the finished product of Indian Point 2 and 3. Now, Indian Point 2 was built connected to Indian Point 1. So they just enlarged the turbine building from Indian Point 1 to house the Unit 2 turbine generator. So here's Unit 2, here's Unit 1. Indian Point 3, they gave it its separate turbine building. And that kind of worked out okay because now it was a New York Power Authority property, and a fence went up between the two units. And one was New York Power Authority, one was Con Edison. We didn't speak to each other for years. And it was, when I got there in 1980, it was like Indian Point 2 did not exist. And I'm sure Chris could probably say the same thing about Indian Point 3. But it was like the plant wasn't there. We didn't know anybody over there. I didn't have a phone number to call over there. But and the other thing was the control rooms are separate. So most nuclear plants in the country, both control rooms are in one room, back to back. Here at Indian Point, they decided to put the Indian Point 2 control room over here and the Indian Point 3 control room over here. So they were separated by about 1,000 feet, so that worked out perfectly. So this is a picture from about 15 years ago. And this is the Indian Point 2 control room. This is called the flight panel, and this is called the supervisory panel. The Indian Point 2 control room had a lot of room because I took this picture from the Unit 1 control room, so they were able to have a lot of space in Unit 2, whereas at Unit 3, our control room was much more confined. We have the same panels, but we had a wall behind us, and there was really no place to go. It was long and skinny. To work in one of these control rooms, like I did and Chris did here, you needed to have either a reactor operator or a senior reactor operator license. You spent a year in school, or even more than a year in school. And at the end of it, you got an exam by the Nuclear Regulatory Commission. And it was not a fun exam, and I spent more time that year than I spent working hard than I did my 4 years in college. You had to learn every pipe, every valve, every specification of the plant. You had to learn all about it. This is a 1984 SRO class from Indian Point 2, and they just got their licenses that day. And this is the chairman of CEO of Con Edison at the time, and this was the NRC regional administrator, Dr. Thomas Murley. And so all these people got their licenses that day. And this girl here in the center, her name is Ann Wynn, and she was the first female licensed operator at Indian Point. There would only be 6 after her. When I put this picture in my book, I had to find all these people to get permissions to use their photograph. And a lot of them were easy to find. Some of them had passed on. But Anne was very tough to find. It took us months to locate her. And we did finally locate her. She lives 2 blocks from my daughter in Connecticut. I mean, they can see each other's homes from where they live. So when we visit my daughter now, we go visit Anne. I had her come to the plant a few months ago. I'll show you that in a second. This is her license, her SRO license, Ann Wynn. Your license is only good on Indian Point 2 or Indian Point 3, not on both. So you had a license just on one unit. It's basically a driver's license for a nuclear reactor, given to you by the NRC. And this is her today. She went on a tour. She crawled around just like she used to. She was amazing. Do you remember her, Chris?
Yes.
John, do you remember her?
No, I don't.
No. Some other equipment that the plant has, these are main transformers. So as I mentioned before, the 22,000 volts comes out of the turbine building from the generator, goes through these things called bus ducts, which are hollow, comes into these transformers, and the voltage is stepped from 22,000 volts up to 345,000 volts where it's transferred onto the Con Ed system. So each plant had 2 of these main transformers. These are circulating water pumps. Each plant had 6 of these. They pump cold river water into the plant to cool various systems. Most of the pump is down below us. This is just the motor. This is a main boiler feed pump. Each plant had 2 of these. They're steam driven. They pump the water from the turbine, from the condenser, back into the steam generators, get turned back into steam again. These things pump 15,000 gallons a minute. They were extremely loud. This is a diesel generator. Each plant had 3 of these. So this is a diesel engine back here. This is a generator that made 480 volts. Nuclear power plants require power to shut down safely. You can't just take all the power away and they shut down. You need power to cool them down. So if we were to lose the plant, if the plant were to shut down, and we were to lose off-site power from the Con Ed system at the same time, these diesels would start up in 10 seconds and provide all the power needed to safely shut down the plant. We're about to sell them, actually. This is the spent fuel pool at Unit 3. So as I'll get into in a minute, but as I mentioned, there was 193 fuel assemblies in the reactor. Every 2 years, we replaced about half of those fuel assemblies. So when they came out, they had to go somewhere. And this is the spent fuel pool. This is where they went. This has about 1,300 locations for spent fuel. So it lasted us for many decades. This is a closer view of the spent fuel pool. You can see these are all spent fuel assemblies which are spent either 2 or 3 cycles, 5 or 6 years in the reactor, and once they're done, they come into the spent fuel pool. And this is what it looks like inside the containment building. So this is Unit 3. These are the 4 steam generators. You can see the steam lines coming off the top. Down under these concrete blocks, way down here is the reactor under the floor. All that's visible is the head down here, the reactor cavity. There's the manipulator crane that I told you about earlier. It travels on rails over this cavity when all this is removed. This is the 95 foot elevation, whereas Unit 1 was the 108. This is the 95. And there's the 95 foot equipment hatch. When the plant is shut down, we take that hatch off and large equipment can go in and out of the building. Training. Everybody in the plant, whether you're maintenance, INC, security, operations, everybody had a training program. This is the Unit 3 simulator, and that's the instructor's booth up there. It looks exactly like the Unit 3 control room. This is where we trained initially to get your license. This is where you were examined periodically. So on a typical schedule for a licensed control room operator, you worked a 5-week schedule. You worked 4 weeks on the watch, around the clock, and the 5th week you spent in training, in the simulator and in classroom. And typically you'd show up Monday morning in training at 7 o'clock, they'd put you in the simulator, and they'd examine you. They weren't interested in how you were going to be at the end of the week, they wanted to know how you were for the previous 4 weeks. So this is where we spent a lot of painful time. This simulator did many things that the plant never did, as far as giving us aggravation. This is also in the simulator. Here's 2 senior reactor operators discussing something with a simulator instructor. And they're looking at a print right here, or a drawing. Many of these systems that are on these drawings, SROs have to have memorized. So either in requalification training or in initial examinations, you had to be able to draw these systems on a board. We also had a fire brigade. Our fire brigade was always 5 people, a fire brigade leader, and four fire brigade members. You went to fire school for about a month to get qualified to be on the fire brigade. And then you spent 2 days a year at the Rockland County Fire Training Center here in Pomona. Not our favorite 2 days of the year. We had unannounced drills at the plant that we'd have to respond to. And this is some photos from Rockland County. That's our instructor there, Scott Bianco. This is kind of an interesting scenario here. They would blow a flammable liquid out of this flange, which loosened up. And the flames were everywhere. What you had to do here is the fire brigade leader stood in the center, and one side had their nozzle down low, one side had their nozzle high, and you had to push the flames away from you while you walked in half a step at a time until you could finally reach this valve here. And the fire brigade leader would finally be able to reach it and close it. And again, not our favorite 2 days of the year. So two things I wanted to mention. As I mentioned before, Con Ed was Unit 2 and NIPA was Unit 3. But in 2000 and 2001, Entergy came in from down south and they bought both plants. And we became together again. So it was a very strange thing. They took the fence down, they opened up the bridge, and you walked across and there was a whole other nuclear plant. It was unbelievable to most of us to see the other side that we had just looked through windows at over the years. And the other thing is that everybody at Indian Point had really two jobs. They had their normal job and they had an outage job. So an outage is when the plant shuts down for maintenance and refueling. So outages would happen every 2 years. Indian Point 2 would shut down on the even years in the spring and IP3 on the odd years in the spring. And originally, years ago, outages were kind of long and not really well coordinated. They would be 100 days long. But over the years, efficiency became number one, and we got our outages down to 25 to 30 days. So during those outages, we would do refueling and many other maintenance activities, replacing pumps, valves, all sorts of calibrations on controllers and power supplies and bistables, and everything had to be taken apart and checked out and put back together again. And we brought in about 1,000 supplemental workers. So people would travel the country going from nuclear plant to nuclear plant to support these outages. So we were bringing about 1,000 people. They lived in trailers, they lived in motorhomes, they lived in local motels or local apartments because the permanent workforce wasn't large enough to perform these outages. You could tell an outage was coming because every January, as Chris could attest, we would get new fuels. And this is new fuel arriving at the plant. These containers each hold 2 brand new fuel assemblies. They came from Westinghouse in Columbia, South Carolina. And the outage would be in March, so all the fuel had to be delivered between January and February. And when you took the top half off of one of these casks, this is what it looked like inside. Here's 2 brand new fuel assemblies. They're kind of locked in there. They have accelerometers on them to make sure that they weren't bumped unnecessarily on the way here. We could tell if they had hit a large bump or something like that. And they came in a yellow bag. And this is one right here that's been taken out of the yellow bag. It's being inspected. And there's Rich Motko, as Chris knows. And we've just taken this one out of the cask and we're lowering it into its dry rack. We're looking at it very closely. What are we looking for, Chris? We're looking for dings and dents and burrs and scratches?
That's right.
That's right. Anything we found, Westinghouse had to resolve for us. We would either send it back or they would come and evaluate it and deem it whether it was acceptable or not. And this is looking straight down at one that we just let go of in the dry racks. You can see the top here. You can barely see the tops of the fuel rods under there. Right there's 2. They're all over the place. 204 fuel rods. And this is a picture somebody took from the 80s of me doing the same thing, lowering a brand new fuel assembly into its dry rack. I think that was a NIPA publicity photo, I believe. Probably like 1985. And here's the dry racks. As the fuel came in, we stored it in these dry racks. We had 76 locations, 76 or 72 locations. And this is a bunch of fuel assemblies. Each one, again, was about 13 feet long, 8 by 8 inches, weighed about 1,500 pounds, and they cost about $1 million each. Once we got all the new fuel, and we're happy with it, it was time to put it in the water. So here, a fuel assembly is being lowered into what we call the new fuel elevator. This gentleman will lower it into a box. He'll disconnect the tool at the top, and the box will go down into the water, all the way down, 25 feet, and then another person will come over on this crane over here, and he'll pick it up out of the box and store it in an underwater location, getting it ready to go into the reactor during the refueling. This is the 80-foot airlock. This is the way you enter the containment building. This is the first thing you see the first night of the outage. It has an inner door and an outer door. It's like a submarine hatch, kind of. So you open the outer door, and you go in. You close the outer door, and then you open the inner door. You could never open both doors unless the plant was cooled down below 200 degrees. So here's a crew going into containment. This is typically first night of an outage. It's very hot inside. It's very noisy inside. And we're going to go in and start disassembling the reactor and other things. And again, you've seen this picture, but this is what it looks like when you go in. It's just very noisy. It's 120, 130 degrees. We typically had 30 or 45-minute stay times in the building once the plant shut down. But as the plant cooled down, you eventually got into where the stay times went away completely. Now if you go down into the reactor cavity, now we're down on the 69-foot elevation here. The 95-foot is up here. So behind this insulation is where the reactor head is living. And these ductworks here cool the head with fans that are up here. So this is the first thing you do is you start taking insulation off to get to the reactor head. This is all part of what we call reactor disassembly. And here you can see the insulation is off. There's the reactor head. And there's the 54 bolts that hold the head onto the vessel. Each one of these bolts is 6 to 7 inches in diameter, and each one weighs 700 pounds. So the way they're loosened is there's a machine that goes on top of each bolt. There's 3 machines. We space them 120 degrees apart. And we grab onto the stud and we pull it. And you loosen the nut a turn and you let go of it again. And you go around, you do that one time. And the second time you loosen the nuts all the way. The nuts themselves weigh 70 pounds. So here's the head. It's been unloosened and all the studs have been removed. And now we're lifting it off the reactor vessel. So it's coming from the 69-foot down here to the 95-foot where it has a stand to go into. And once it's on the floor, just out of this picture over here, now we fill the whole cavity with water, 400,000 gallons, and we're looking straight down into the reactor right there. I took this picture in like 1985. I climbed up on the polar crane, I opened up a light hatch, and I looked straight down and took this photograph. And you can see the manipulated crane here, ready to do its job, and there's the rails that it runs on over the reactor. And this is looking down into the core, and you can see the tops of the 193 fuel assemblies. And here's a photograph of most of the core has been offloaded here, at least a good part of it. And you can see another fuel assembly being raised up into the mast of the manipulated crane. Unloading the core took about 48 hours, around the clock. And every time a fuel assembly was lifted, it went into the corner of the reactor cavity. It was put into a basket called an upender. The upender laid it down onto a train track. It was pushed through a tube out of the building into the spent fuel building, where another box raised it back to vertical, and a crane over there put it into the spent fuel pool. This is another picture of the core, and here, this is a core reload photo, and the way you can tell that is the old fuel is glowing blue, and the new fuel is silver in color. It's not glowing at all. So the fuel, all the fuel is taken out of the reactor, all 193 fuel assemblies. Half of them are replaced, and when we come back into the core for the core reload, we've got new ones and spent ones that'll be the next core. So this blue glow is called Cherenkov radiation, and I'm sure Chris could describe it better than I could, but it has to do with the speed of particles in water versus the speed of particles in air. They give off a certain wavelength of energy which turns into this blue light. Very pretty. And here's another shot of the reactor cavity. You can see there's the reactor. Looks like it's on an angle, but it's really not. And there's the manipulator crane, and you can see the mast going down into the reactor. And you can see a little bit of a blue glow there, so this picture is either putting an assembly in or taking one out. And you can see the reactor head on the floor in the background. And here's the manipulator crane operator on the console. He always knows where he is over the core. He knows whether he's latched or unlatched to a fuel assembly. He can tell his exact location. He can tell the weight of the fuel assembly. And here we are in the spent fuel building. This fuel assembly just came out of the reactor, and it came through the little railroad car system, what we call the fuel transfer system. And it's being put away into the spent fuel pool. So once all the fuel is out of the reactor, now we can do maintenance on all sorts of other systems around the reactor, which we couldn't do with fuel in the reactor because of water levels and things. So Plant maintenance is going on this whole time, but this allows us to do further maintenance on systems connected to the reactor once the core is completely out of the reactor. And here's a closer look of a spent fuel assembly getting put into a cell in the spent fuel pool. And of course, during the outage, lots of other maintenance going on. Here's a low pressure turbine being either examined or replaced. You can either examine blades, inspect them, you can replace blades, you can replace the whole turbine. We've done everything over the years. Here's a main transformer being replaced, which was a huge job, sliding it out of the transformer yard. This is a reactor coolant pump motor. It's a 6,000 horsepower motor being replaced. This is up on the deck on the 95-foot elevation in containment. This is a picture from the late 70s, and the reason I put it in here is working in containment wasn't really a lot of fun. I mean, first of all, it's a radiologically controlled area, so there's radiation on various things, which you're briefed on by radiation protection technicians, where to go, what not to touch, where you can go, where you can't go. And you have to wear these coveralls all the time, so in case anything does get on you, it comes off with the coveralls. But you're not allowed to touch your face. There's no bathrooms. There's no water. You scratch your face, and all of a sudden you might get something on your face. So, typically we did 3-hour jumps in containment, and after that you came out for 3 hours. That was typically the routine. This is INC Department Instrumentation and Control. They're in the control room at Unit 2, and they're testing relays. And this went on around the clock during outages. There was hundreds of relays and bistables and power supplies, all to calibrate and check out. This is the maintenance system, maintenance department putting a pump back together again. Everything in the plant is huge. You need cranes to move everything. It's like taking your car engine apart, but you need a crane to move everything. I wanted to talk a little bit about the people and the community of Indian Point. So here's Mike and Gail Rue. They both are lifelong Buchanan Verplank residents. They both spent over 40 years in the operations department. And Mike is still at the plant today. And this is their son, Timmy, who worked at the plant for a number of years until he went off to another nuclear plant when Indian Point shut down. This is my old buddy, Steve Bridges, sitting in the Indian Point 3 control room in the mid-'80s. And he's the control room supervisor at the moment. And the scary thing about this picture is I can recognize my handwriting on the board here. But this is his daughter, 40 years later, doing the same function. Joanna Bridges. This is the Mooney family. So Jim Mooney Sr. is back here. He was an instrumentation and control supervisor at all 3 units. And he's at a family day with his family at Indian Point. During construction, they let you come in and look around and show your family what was going on. And this is his son, Jim, and his other son, Mike. And I work with both of them. They're both retired now. This is 1970. This kid, he came to the plant in the summer of 2011 as a summer engineering intern. He worked for the summer at the plant. And today he's my son-in-law. Entergy was very good to the local community. They were the major sponsor for the Jack-o'-lantern blaze in Croton-on-Hudson every year. They were the major sponsor for the emergency room at the Hudson Valley Hospital in Peekskill. This is Mark Pasquale, who played Santa Claus at the plant for over 30 years. He raised funds for the Rosary Hill in Hawthorne, New York. It's a facility for terminally ill cancer patients. His dad started this fund in 1961, called Christmas Gifts for Rosary Hill. We also had a lot of fun at Indian Point. We celebrated things whenever we could. So if we had a successful outage or we had a record run or something of that nature, we would always have an employee appreciation day. This is the Indian Point band playing on the simulator. We call it the veranda. One summer afternoon. We always also ate very well at Indian Point. The local delis and local pizza places, and they loved us. They still love us. This is another Employee Appreciation Day. This picture is from the Unit 3 control room. This is celebrating 40 years of power operation at Indian Point 3, August 76 to August 2016. So in 2017, Entergy entered an agreement with New York State to shut down Indian Point, called the Shutdown Agreement. Indian Point 2 was shut down on April 30th, 2020, and Unit 3 on April 30th, 2021. And it's a long story. We spent years in the legal system battling the state of New York for our continued use of the Hudson River. At this time, both plants were going for their license renewals. Their original 40-year licenses were about to expire, and we were looking for a 20-year extension, just like every other nuclear plant in the country. It takes about 5 years to get a renewal. We started 5 years early, going through all the necessary paperwork and inspections and everything to get the license extension. One part of the license extension was the continued use of the Hudson River. The state didn't want us to use the river anymore, so they fought us in court for many years. And at that time, Entergy saw the price of continuing to operate the plant. They looked at the price of natural gas, which was low, and they decided to shut the plant down. So that was in 2017. We had 4 years to go, basically. So this video, you'll see what it sounds like inside the plant, what it looks like when the plant was operating. This is Unit 3. I'm walking to the north towards Unit 2. This is the Unit 3 turbine hall right here. And Unit 3 is at 100%. And you'll see the shaft spinning here in a second. So right here is the connection between the turbine and the generator. And it's the only place you can actually see the shaft rotating right there. 1800 RPM. And there's the 3 low pressure turbines that we're coming up to right here. And now we're coming to the end of the turbine. This is the high pressure turbine. And when I turn around, you can see where the 4 steam lines from the 4 steam generators came into the high pressure turbine. So right here at the north end of the turbine ball, you'll see the 4 steam lines right there. There's 2. There's 2. That's the high pressure turbine right in there. Now we're going to walk across the bridge and go over to Unit 2, which is also operating here. So here we are at Unit 2, and as I mentioned, it's got a slightly different generator, which is a General Electric generator. But they have the same space in here that you can see the shaft. I took this video in 2017 when both plants were still operating together. And there's the shaft spinning. Unit 2 always had better graphics on their turbine than we did. At Unit 3. They even had a big Yankee symbol at one point, and the Met fans made the plant management take it down. And the same high pressure turbine as Unit 3, and this is the end of the turbine hall. And there's the 4 steam lines. Same thing as Unit 3. Now this video, the video I'm going to show you now is on April 30th, 2021, inside the Unit 3 control room, the final shutdown of Indian Point 3 reactor. So the person you're going to see is the control room supervisor. His name is Kevin Brooks. and he would give his direction to the reactor operator standing at the flight panel to trip the reactor, and that's what you'll see here.
Last time, it is 123. Trip the reactor. Last time, trip the reactor. That's correct.
You can see those red lights right there that just came on. That's the control rods falling into the core to shut down the fission process.
All rods indicate less than 20 steps. Neutron flux is decreasing. Reactor trip. Understand reactor trip. That's correct.
So that was the final reactor trip at Indian Point. The one thing about that trip right there is that was a world record run for Indian Point 3. It started up in 2019 in the spring after its final refueling, and it ran continuously till that day. That was the 753-day continuous run. The previous record for a light water reactor was around 690 days, I believe. So that was the first time at Indian Point in its whole life that it ran refueling to refueling. We call it breaker to breaker. But so it was a fitting way for us to go out. We were very proud of that fact. We ran 753 days continuous operation without any issues. The plant ran best at the very end. This video is the final core reload video. So here we are taking the last fuel assembly out of the core on May 11th. This is 11 days after we shut the reactor down. And this is the final fuel assembly coming out of the reactor and going up into the mast. And now the core is empty. And here comes the upender basket to receive that fuel assembly. So the fuel assembly is up here in the mast. It's going to come down into the upender. And there it is. This is all underwater. And there's the top of it. And now the mast just let go of it. And now the upender basket will lay the fuel assembly down to a horizontal position. So that's the last fuel assembly to go over to the spent fuel building and get stored. So today, Indian Point is owned by Holtec International. That's the company who bought it to decommission the plant. We have about 700 employees right now from the maybe maximum of 2,000 we once had. Right now we're cutting up the reactors, their internals, and all the parts that keep them connected. That project is known as vessel segmentation. That goes on, that's been going on for the last 2 years, since 2021. The other project is called pool to pad. So pool to pad was to take all the fuel in both spent fuel pools, put it into dry casks, and put it on a pad that's located at Indian Point on the site. So those are the two major projects, vessel seg and pool to pad. So as far as vessel seg is concerned, this is inside containment, and this station here is positioned right next to the reactor cavity, which is right here. And this is the cutting station. And you can see here there's a huge saw, 5 feet in diameter. And that's a part of the reactor down there in the cavity underwater. And this thing just chopped it to pieces. It took several weeks, but it finally took it all apart. And all the pieces were placed in boxes in the cavity and then covered up and shipped out to Texas. So that's one project, vessel seg. The other project is pool to pad. This is called the high storm canister. It's about 2 feet thick of concrete. In the center of it is a hole, and in that hole is what looks like a soda can, basically, but it's called a multi-purpose canister. And inside that multi-purpose canister are 32 fuel assemblies that just came out of the fuel building. And that canister is welded shut, and it's drained of water, and it's dry, and it's filled with helium. And now this canister will be placed up on our dry cast pad. And the way it works is it sits up there, and this is the vertical cast transporter that moves them. You can't see this picture either, but let me see. All right, so at the bottom here are vents. They're holes. And air enters the canister in the gap between the concrete canister and the metal soda can inside. And the air goes up along the outside of the canister, it cools it, and the hot air comes out the top. This is a passive system. The fuel has now been cooled down far enough to where it can be cooled by air rather than water. So now it will get moved up to the pad where they are right there. This was the last canister we put up in February of this year for Unit 2. So that at this point, all the Unit 2 fuel was out of the pool, and the pool was empty. And just 3 weeks ago, we finished the same project at Unit 3. So now all the fuel from both plants, actually all 3 plants, Unit 1, 2, and 3, is now on the dry cast pad. And it looks like this. So there's 127 casks here. And this is all the fuel from Indian Point 1, 2, and 3 that was left. So now both fuel pools are empty. And what we're doing here is the plant was surrounded by what they call the protected area, protected by cameras, guards, fences, key cards, all sorts of things for the last 45 years. What's happening now is they just built a brand new security building right here. And in the next few weeks, this is going to be the protected area only. Instead of, it's now part of the plant's protected area, but they're going to reduce it to just the pad. So now the plant is going to be very easy access. There's no spent fuel left. There's nothing left there. All the fuel is here. This will be guarded 24/7 for the next 25 to 30 years, just like that, as they take the plant apart. So that is all I have, folks. If you have any questions.
So 25 to 30 years, the spent fuel will be stored there.
Yes.
And what happens then?
Nobody knows. The Department of Energy, which was supposed to start taking this fuel in 1994, didn't. So companies had to develop this dry cast storage method, which is basically 30 years old now. The DOE came to the plant about 6 months ago and told us their plan. Their plan, they don't know what to do with the fuel. So they had the plan of Yucca Mountain. That got shut down years ago out in Nevada. What they're doing now is they're doing 2 things. They sent out 120 questionnaires to communities around the country, looking if you were interested in having a pad or having a repository near you. They got 40 positive responses back so far. That's one avenue. The other avenue is Holtec is building their own spent fuel storage area in New Mexico, and other companies are looking at building their own. So at the end of the day, the DOE is either going to choose one of their own sites that they choose and build, or they're going to choose a site that somebody else builds. But eventually, they're going around to all the plants right now. They're characterizing each plant, whether the fuel has to be moved by rail, truck, or barge, or all 3 or 2 or whatever. In Indian Point's case, it's truck and rail. And they're going to make an order, but it's not going to start for about 25 years. So this plant will be there, and these 30 security guards will be there for a long time.
So that is still low-level radioactive material, or
Well, this is very radioactive material, but it's stored in such a way that there's nothing measurable outside of it.
okay. So it's still highly radioactive.
Yes, fuel is highly radioactive,
And it stays radioactive for
thousands of years.
Right.
So it's got, and the place they're talking about bringing it to is an interim place. They haven't even thought about the long-term place yet. They're looking at an interim place, which is 25 years. Yes, sir.
When they first cited this Unit 1, was there any discussion at that time about earthquakes?
It was all analyzed to death at that time. I mean, you could read volumes of books in our FSAR about the whole seismology of the site. It was evaluated. I can't give you details because I don't know the details, but the fault lines, all those things were looked at.
Brian,
Yes.
would you care to share your opinion as to whether or not it was a mistake to shut down Indian Point?
Well, we all think it was a mistake. The plant was built very well. And it was made so the guys like us could run it. Okay? I don't know if you can understand that, but it was made so that even if you made a mistake, It covered your ass somehow or another. It was built with many levels of protection. And forget about what you read. The plant was run very safely. We worked our asses off to make sure this plant was safe. And it could have run in its present condition for another 20 years. And the plants upstate got money to continue. This plant did not. So all the plants upstate, 9 Mile, Gannett, they got money to run, and we didn't. So it was all political, our former governor. And this plant could be running right now. And as we take it apart now, you know, although we've learned what this pipe was made of and what this concrete, now that we're taking it apart, holy, they built this plant to last forever.
They used to.
They knew what they were doing back then. Yes, sir.
What would limit its lifespan past the next 20 years if you could run it?
Kind of the Achilles heel of this plant may have been the service. You know, we took a lot of water into the river, and it liked to eat a lot of things. So the service water system that we call it, or circulating water system, which went throughout the plant, like the veins of the plant, were constantly being replaced with new piping. You know, piping was rusting or degrading. We constantly had to work on that. The reactor vessel probably could have won many, many more decades. It was constantly being tested and examined for radiation, embrittlement. Anything else we could replace. Like, for instance, that reactor vessel head that you saw, 170 tons, every plant in the country has already replaced their heads with a new modern head that came apart much easier. Indian Point started looking at that 15, 20 years ago, and we had 2 giant chunks of metal sitting in Korea waiting to be machined. And then when they decided that wasn't going to happen, those chunks got sold. And so even heads can be replaced. You're not going to replace the reactor, but everything else can probably be replaced in the plant. And we spent years replacing motors and pumps and valves and pipes. And so I'm not sure what would have been the final death knell of Indian Point, but whether it's the service water system because it just had to replace too much piping and it was too expensive, or the fact that the reactor then had reached its final limit, I'm not sure. Yes, sir.
Just to help, if the service water system did not interact normally with the radioactive areas
Yes,
or
it's
the
separate.
nuclear areas of the plant, it was separated by tubes.
Yeah, I mean-
But the conventional side, where the turbines were and things like that, that service water, it's river water, it's brackish, so that's what.
Causes lots of problems.
Yeah.
Could that radioactive material be utilized in a new nuclear power plant?
Well, that means you'd have to reprocess it, which is illegal in this country. So Jimmy Carter saw to that.
For what reason?
I'm not really sure.
What was after 3 Mile Island?
Yeah, it was 3 Mile Island in 1978, whatever it was. I put it into, so we were, up to that time, Indian Point 1, all of its original fuel went to a place near Buffalo called West Valley, New York. It was shipped there in the 70s, in the early 70s, and it was reprocessed into other material, but that got stopped. So we ended up with some Indian Point 1 fuel here left over that we put into those 5 casks right there, the short ones. And so no, we can't reprocess in this country right now, but it can be, that can occur. Yes.
So you mentioned 700 workers right now.
Yeah, so.
Is there a plan in place for?
Here's the plan is that we just recently, so we've been releasing radioactive water to the Hudson River for 60 years. Every nuclear power plant in the country is on some body of water. That's how it cools, whether it's a lake, a river, a bay, an ocean, and we have the Hudson River. So there are federal limits for releasing water, for radioactive water, for whatever it is, mercury, lead, doesn't matter, there's a limit for everything. It's never zero. You can't be zero because there's too many industries that rely on these things to get rid of material. So we've been releasing water into the river for 60 years, since 1962. What happens with water is wastewater from various pumps and valves goes into a tank, and it dribbles in there, and eventually the tank reaches 10,000 gallons. And I would get a call in the control room, saying that, oh, 31 monitor tank is at 85%. And I would tell my field operator to isolate that tank, stop the water from going in, switch over to 32, right next to it. And I would call the chemist, and I would put that tank on recirc for 4 hours. We'd mix it up. And the chemist would go in after 4 hours, he'd take his sample, and 2 to 3 hours later, he called me in the control room and said, here's the numbers. And he gave me these numbers that went into a computer program. And for 32 years, I was in the control room. Well, that number that he gave me was way, not even close to any federal limit. So my pump was able to release 60 gallons a minute. My release rate based on that activity was 500 gallons. I mean, I could go the maximum the pump could do, basically. So what I would do is I'd sign the permit. I would turn a key in the control room, which let a field operator open up a valve, and that 10,000 gallons went into the river every couple of days. So that's how it worked for 60 years. Now, 2 months ago, the governor signed a bill, no more releasing radioactive water into the Hudson. So now because of that, we have large amounts of water at the plant that are stuck where they are, and we can't take those buildings apart now. So our decommissioning plan, which we've had for the last 2 years, has changed drastically in the last 2 months. So at the end of this year, we're going from 700 employees down to about 300. We're going to continue on with the pool to pad project is completed, but the vessel segmentation can continue for about 2 years, and then we run into a wall. We can't do any more because we have all this water. So we're going to shut the site down for about 8 years until we either win a legal battle or the water gets to a point where we can release it below a certain limit. But right now, that is the plan. Is a lot of people are leaving December 29th, not to return. We're going to continue to work for 2 years, and then shut the site down. And it'll look just like that for the foreseeable future. Yes?
The idea with the large containment vessel, the concrete dome, was to prevent attack or was to prevent?
No, it's to prevent. So the reactor coolant system that lives inside of there, when it operates, it's 2,200 psi, pounds per square inch, 550 degrees. So if one of those huge pipes that connected the reactor to the steam generator, for instance, which are 30-inch pipes, they're 3 inches thick. If one of them were to fall off during operation, all that water would flash to steam, and the accident pressure is 40.6 pounds or something like that. That building is meant to contain that pressure. That building has a burst pressure, I believe, of 150 psi, and we had it tested every number of years. So that's what it's there for, to protect a failure of the system inside from getting out.
What do you do at that point? Just release it slowly?
After an accident like that? Well, fortunately, we don't have any situations like that. TMI, I mean, they spent decades recovering that plant from this accident. That would be something that had to be decided in the future.
But you can reduce the pressure. There's methods and systems designed to reduce
the 40.6 pounds that I mentioned that Chris is talking about, that would get reduced very quickly by systems we have in containment, spray systems and all sorts of stuff. But now you've got all this water on the floor, you've got a broken system. That would be there for a long time like that until it's decided what to do with it. Yes?
Brian, what do you see as the trajectory for nuclear power in America 50 to 100 years?
Well, right now, what's gearing up right now is small modular reactors. So this was phase one of nuclear power, pretty much. Phase two is going to be these SMRs, which are smaller, simpler, more passive systems built in. They don't rely on power or other things to safely shut down or to operate. So there's many companies in the country right now, including Holtec, that's designing and building small modular reactors. So they're going to be like anywhere from 160 to 300 megawatts, as opposed to big guys like this, 1,000 megawatts. They'll be plopped in places. They're kind of modular. So, for example, Entergy owns a plant in out west called Palisades, which is shut down right now. They want to put 2 SMRs there, Entergy owns plants down south, one of them Grand Gulf. They want to put SMR. So wherever there's an existing nuclear plant is a prime opportunity to plop an SMR down and to replace what was there. You've already got the emergency plan, you've already got all the infrastructure for another nuclear power plant. So there are many companies out there right now designing and building. Many people that I work with who now don't have a job in January are going off to work on SMRs. Yes?
How do they compare in capability, or how much they produce to something like that?
The SMR? Well, like I said, this is 1,000 megawatts each. They're 160 to 300 megawatts each. They're smaller, they're easier to build. Parts can go on a rail car.
And the purpose, would they, I mean, they can power that much, no?
No, but you put a 4-pack there and now you've got something.
They can power neighborhoods, homes?
Well, New York City, I mean, this place did 25% of the state. So, I mean, there are going to be companies in this country that have a large facility somewhere. I know there's a company in Texas looking at it right now. They want to have their own SMR, just to power themselves. Someday when we go back to the moon, you're going to need a reactor. You're going to need something. That's the next wave.
Getting back to the basic, you were taking water out of the Hudson for cooling.
Right.
And then putting it back in the Hudson after it was cooled down.
Yes.
So what has this done to our river?
Nothing that we can, nothing that our experts can tell. The fish love the outboard structure. It's nice and warm there. We used to go fishing there and crabbing there, but it's a few degrees warmer. But other than that, nothing.
It hasn't. And the level of the water doesn't change?
Oh no, of the river?
Yeah.
Oh no, we're a drop in the ocean.
Okay.
And there's even limits on how much
How
the
much
water,
they can take.
temperature of the water can increase. So there, you have to control that.
Yes, sir.
Did you ever work through the amount of, I don't know how many, what the units you want to use, but how many tons of fossil fuel were not burnt because of the power that was generated at Indian Point? You ever do that math?
I haven't, but the company has, and you know, if you go to our visitor center, it used to show 3 barrels of oil or something. Remember, Chris?
Right.
Equal to a pellet, you know, some amazing amount of oil that you needed to make the same power as this little pellet would, of which there are thousands in the reactor. But I haven't done the math. Yes.
So I have 2 questions. You said 40 towns have agreed to house these?
40 communities in the country is what the DOE told us, came back with positive responses that they would, you know, it's jobs.
Is that the benefit to them would be
Oh,
jobs?
they'd be working there
They
forever.
wouldn't be paid, you know, it would be jobs.
They would love, you know, it's a depressed community, whatever it is, and they would love to have a business there.
And what about, has there ever been anything positive proposed for this? nuclear
site?
waste? No, for the waste
Oh,
itself.
for waste, no.
Nothing
Like
positive?
the DOE can't make up their mind on anything. It's the federal government.
Say no more.
Say no more.
Was there ever a proposal to put a gas-fired generating plant there?
Back in the day or today?
anytime.
No, not that I know of. You know, back in the day, they wanted to build a nuclear plant, and today it's just way too different than a gas burner would be. You have to rip the whole place down and start over again. And nobody knows what's going to happen here someday. The property is owned by Entergy. That pad is going to be there for a long time. There are 320 acres. There's 60 acres here in the north side of the plant, 64 acres between the Cans and Lens Cove that Buchanan wants us to give them right now because they want to build housing or something. But right, if you talk to the mayor of Buchanan, she doesn't want housing here. She wants business here. She wants tax money. So she wants another industrial concern to come in. I think Entergy Holtec at the end, you know, will probably keep half this property and put in a battery system or something. They'll come up with something, and they'll sell half the property to some other industry. But housing doesn't pay taxes like a business would. And that's what they want in Canada. They lost a lot of money because of this.
What about an amusement park?
It's well, you know, the joke of the plan has always been an amusement park.
Steamboats. Okay.
Thank you very much, folks.